Hi all, this is Alan with Bothell STEM Coach, and today we're continuing on with the 2019 AP Physics C Electricity and Magnetism Free Response questions, and this is from set 1. And as usual, if there's any corrections I need to make, I'll put them in the description below, as well as there'll be links to the PDF solutions that I put together. Okay, so I have a circuit here with currents, with two 6-volt batteries, 3 resistors, and using Kirchhoff's rules, write but do not solve the equations that can be used to solve for the current of each resistor. So what I'm going to do is I'm going to do a loop, KVL, for each this loop and then this loop. So KVL equations, it's going to be 6 volts minus a voltage drop there, I1, 150 I1, minus 200 I2 is equal to 0. Now do this loop here like this. I'm going to do 6 volts minus 100 I3 minus 200 I2 is also equal to 0. And then I have 3 unknowns and only 2 equations, so I need to relate the currents with KCL, and I can say that I2 is equal to I1 plus I3. So the current coming in equals the current leaving. Okay. So now calculate the current of the 200 ohm resistor. Well, to solve this, there's a lot of ways you can do this. You could do a systems of equations and use matrices and solve it. I'll just do it with direct algebra here. And I think I did this. So 6 volts. First, I'm going to rearrange it. It's 150 I1. And then I'm going to replace I2 with I1 plus I3. And then this equation, same thing. I'm going to do the exact same thing. I say 6 volts is equal to 100 I3 plus 200 I1 plus I3. So these are my 2 equations now. They're in terms of I1 and I3. And so I'm just going to try to combine these. So I1, I have 150 here and 200 here. So that's 350 I1. And this is, then I have 200 I3 left. So that's this equation. And then 6 is equal to I1, I have 200 I1 here. And then I have 300 I3. And if I think about this long enough, I can relate these 2 equations together by, say, multiplying this one by 2/3 or negative 2/3, and I'll get negative 4 is equal to maybe that's not a great way to do it, that one, because I don't want to have like weird fractions. So I'm going to multiply this one by negative 3/2 actually. So this would be negative 9 is equal to 350 times 1.5 is 525. Negative 525 I1 minus 300 I3. And so I'm just going to put that under here to eliminate. I'm going to use elimination method. So this is negative 3 is equal to negative 325 I1. Because when I add these up, right? And so I1 is equal to 3 over 325. And that's 0.00923 amps. And I3 then, I just use either equation to solve. I'm going to do 6 minus 200 times I1. Then divide that by 300. Get 0.0138 amps. Okay, so that is what I got for the currents there. I just want to kind of check my answers, and so I need to, in order to know the current through this, I just simply need to add I2 and I3 together. So I2, my current, is I1 plus I3. So that plus 0.0923, I get 0.0231 amps. Yeah. Okay, so I think that's right. So there we go. So now the power dissipated by the 200 ohm resistor, we're going to use P is equal to I squared R. Because I know the current, I don't know the voltage exactly, so I can't do I times V or V squared over R, but I know the current. So I'm going to do this 0.0231 amps squared times the resistance times 200 ohms. And so my power is going to be this squared times 200. I get 0.107 watts. Okay, good. That checks with the answer key I had before, or how I did the problem before in my solution. So far, so good. The two 6-volt batteries are replaced with a battery with a voltage and a resistor resistance 50 ohms, as shown in the above. The voltmeter shows the voltage across the 200 ohm resistors is 4.4 volts. Calculate the current through the 50 ohm resistor. Well, so I know this voltage is 4.4 volts, and that means this drop across here, like these two are in parallel, it also has 4.4 volts, right? And the current through here, these are in series, so whatever the current is through here is the current through here. So I can just simply do the 4.4 volts divided by 150 ohms. Okay? So I get 0.0293 amps. Calculate the voltage this of the battery. Well, so the way I would do this is here. I have this current is 0.0293 amps. Then I could know this current, right? Because the current through here is 4.4 divided by 200. So this, we'll call this I2. So I2 is 4.4 divided by 200. Not to be confused with the I2 in the previous problem, or the previous setup. So that's 0.022 amps. And so now the current through here would have to be the sum of these two currents. We'll call I1. So I1 would have to equal the sum of these two. I get 0.0513 amps. And so last, if I know the voltage drop here is 4.4 volts and the voltage drop, well, I'm trying to figure out what this voltage is. I know the voltage drop here is going to be I times 150. So I1 times 150 is the voltage drop across the resistor. So I'm going to multiply this by 150 and I get 7, we'll call it 7.7 volts. So this is 7.7 volts. This is 4.4 volts. So the total drop from this point to this point is going to be 7.7 plus 4.4. I get 12.1 volts. Okay. And I believe, oh no, we got more here. Now the 200 ohm resistor in the circuit in figure 2 is replaced with a 200 microfarad capacitor shown on the right. The circuit is allowed to reach steady state. Calculate the current through the 50 ohm resistor. Steady state means the capacitor is fully charged. There is no current flowing through here, so the current flows in series. So you just simply, in figure 2, this is figure 2. Okay. So we know this battery is 12.1 volts. I think you just use the same 12.1 volts. So we're going to do 12.1 volts divided by these three resistors in series. 150, that's 200, 300 ohms. And that's 0.0403 amps. The 200 ohm resistor in the circuit figure 2 is replaced with an ideal 50 millihenry inductor as shown on the right, and the circuit is allowed to reach steady state. Is the current in the 50 ohm greater than, less than, or equal to? Well, for an inductor, when it's in steady state, it's like a short. It acts like a short. So a capacitor acts like an open, inductor acts like a short. So when you short this, there's no voltage drop in this path. The current's just going to flow like this, because the voltage across from here to here is 0, because they're all connected, right? So definitely less than, because the I is 0. I through the 50 ohms is 0. Okay, and I think that wraps up that one. So let me know how you did on the question, and or if you have any questions, or if you notice a mistake that I made. And I'll see you in the next video.